In this video, we're going to work on the ALEKS problem called identifying the enantiomer of a simple organic molecule. This problem provides us with a molecule and then 6 additional molecules. We have to decide of these 6 molecules, we have to decide if any of them are enantiomers of the provided molecule. It could be just one, or it could be multiple, or it could be none of the provided molecules. So this problem is actually pretty tricky. The first thing that I think that you should do when you're working on this problem is eliminate from the options any constitutional isomers. Just get them out of your line of sight. A constitutional isomer is going to be a molecule that has different connectivity than the provided molecule. If a molecule is a constitutional isomer of the provided molecule, it can't be its mirror image. The enantiomers or mirror images need to have everything connected in the exact same way. So this molecule has an OH that is adjacent to 2 methyl groups, and we need to just make sure that all of our options have that same connectivity. Look at this one. This molecule does not have an OH directly adjacent to the 2 methyl groups. There's this gap in between. So that means that that molecule, molecule number 3, that's a constitutional isomer of the provided molecule, and it can't be an enantiomer. The rest of them look like they are potential enantiomers. The second thing that I like to look for when I'm looking at these, I like to look for molecules. I think I'm going to try to write it up here. Molecules with the wedge and dash notation reversed. So that means I'm going to look for molecules that have the same connective pattern, meaning that my methyl groups are going to be over here on the side. My OH on the left side, my OH is going to be sticking straight up, and it's going to have reversed stereochemistry. So instead of the OH group being on the dash, the OH group is now on the wedge. So I'm looking for this exact pattern. And the exact pattern that I'm looking for is that I have the OH, I'm going to say on carbon number 1, and the methyl groups are on carbon number 2 when I am going counterclockwise in the molecular structure. Now, I do want to point out, you might be wondering, why did I not reverse the stereochemistry of the methyl groups on carbon number 2? Why did I draw this as a wedge and the other as a wedge? Shouldn't I have swapped that stereochemistry? This is kind of a trick that ALEKS has done on this problem. These methyl groups, I don't know why it's showing stereochemistry for them, because there's no chirality there. Like, they might as well just be straight line. 2 identical groups on that carbon, those 2 methyl groups, that's carbon number 2 as I've drawn it. That's achiral. So whether I'm drawing this as dash wedge or wedge dash, it doesn't make any difference at all. Okay, so I'm looking for a molecule that has the OH group on the wedge. That's right here. This is the only one. OH group on the wedge, and the 2 methyl groups are going to be counterclockwise to it, which would put them right here. In molecule number 4, which is where OH is on the wedge, the 2 methyl groups are counterclockwise, and that means that this is not an enantiomer. Whew, it's tricky. Okay, so the third thing that I'm going to look for is when we draw. Oh, I realized I lost my methyls over here. The third thing that I'm going to look for is the other method that we have for drawing in an enantiomer, which is where we do not change wedge versus dash, but instead we change the relative position of the substituents in the molecule. So basically a true mirror image. So looking at this versus this, I've kept my OH on the dash. I've moved the 2 methyl groups from the left side of the molecule to the right. And this is going to be where I start at carbon number 1, I go to carbon number 2 in a clockwise direction. So with these molecules down here, I'm looking for OH on the dash, yes, 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 and yes. And I'm looking for the methyl groups to be clockwise. In this one, clockwise is this direction, so that is also not an enantiomer. Here's our OH, and the methyl groups are, I want the methyl groups to be clockwise. The methyl groups are counterclockwise. So this is also not an enantiomer, going in the wrong direction. Here's our methyl group, or here's our OH group on the dash. The methyl groups again are counterclockwise. This would be the clockwise position. No, I guess I could have just seen that they are literally the exact same molecule. So that's not an option. This one, here's our OH group, and this would be the clockwise direction. So this is also not an enantiomer. And that means for this particular molecule, or this problem, none of the provided molecules were enantiomers.